Hi students, as you know, NDA has introduced a new unit in the chemistry syllabus for both the NEET and JEE from the year 2024 onwards. The new unit included is the principles related to practical chemistry. Since it is a newly introduced topic, the necessary study materials may not be available in print and visual media. But you need not worry. I am uploading video classes through my YouTube channel explaining the theory related to chemistry practical, which include a lot of multiple choice questions and their well explained answers. By the way, I am Dr. Siriak Matthew, a retired associate professor in chemistry. The purpose of my channel, Chemistry Master, is to upload video classes related to topics in chemistry within secondary, undergraduate, and postgraduate levels. At present, I am uploading video classes related to NEET, JEE Main and Advanced, and other entrance examinations. There will be a set of video classes for each chapter. In the present set of videos, we discuss the principles related to practical chemistry. This set includes 6 video classes. The first one, titled as Principles Related to Practical Chemistry, Part 1A, explained detection of extra elements and detection of functional groups. The second, titled as Principles Related to Practical Chemistry, Part 1B, contains multiple choice questions related to Part 1A. Part 2 explains preparation of some organic and inorganic compounds and a titrimetric analysis. Part 3, qualitative analysis for anions, and Part 4, qualitative analysis for cations. The Part 5 explains some physical chemistry experiments. At the end of each part, multiple choice questions related to that part are explained. Even if you go through a handbook of chemistry practical several times, you may not be able to remember the experiments and the theory behind it. But an audiovisual presentation will catch your attention. That is why I have introduced a lot of animations in these video classes so that you will get a feel of doing the experiments in the laboratory. However, animations never represent the real situation. And this is not an instruction manual for doing the experiments in the lab. The main purpose is to make you understand the theory behind the experiments. In the laboratory, you have to take several precautionary measures while doing the experiments. For your convenience, I have introduced video chapters or timestamps in the description part of the videos. This will help you to watch and rewatch separately the different topics explained in a particular video. The links for other videos are also given in the description part. You can easily move to any of these 6 videos using these links. I hope these video classes will definitely help you to understand the theory behind the experiments. If you like the video, please subscribe my channel and forward to others. You can expect similar video classes from other chapters of Class 11 and Class 12 Chemistry soon. In this video, we discuss some multiple choice questions related to topics studied in the video. Principles related to Practical Chemistry Part 4, Cation Analysis. Question 1. Match the color of the flame with that of the cations. Color of the flame viewed by naked eye. Probable cations. The options are 1, 2, 3, 4. Green flame with a blue center. This is given by copper ions. So we connect A to 2. Then crimson red, that is strontium. Apple green flame is given by barium. Apple green or grassy green. Now, only one remain is brick red, and we know it is calcium. So, A2, B1, C4, D3. So option 3 is the answer. So this is the table, that is naked eye through cobalt glass, ions detected. Green flame with a blue center. With a cobalt glass also we get the same color, that is copper. Crimson red, and through cobalt glass it is purple, that is for strontium. Apple green with a naked eye. Bluish green with a cobalt blue glass, that is barium 2 plus. Brick red with a naked eye, and through cobalt glass green, that is calcium 2 plus. Question number 2, an assertion reason question. To carry out flame test, the given salt is made into a paste using 2-3 drops of concentrated HCl. Reason: any concentrated mineral acid can be used for making the paste for flame test. Option 1, both assertion and reason are correct, and a reason is the correct explanation for assertion. Both assertion and reason are correct, but reason is not correct. Assertion is correct, reason incorrect. Both assertion and reason are correct. And we know that assertion is correct. That is, to carry out flame test, the given salt is made into a paste using 2-3 drops of concentrated HCl. We have studied that concentrated HCl is preferred to carry out the flame test. This is because the chlorides of several metals impart characteristic color to the flame because they are volatile in non-luminous flame. Hence, HCl is preferred. So the reason is wrong. Any concentrated mineral acid cannot be used. So the correct answer will be option 3, that is assertion is correct but reason is incorrect, and that is the correct option. Question number 3, two statements are there. Statement 1, during flame test, the flame color is generally observed through cobalt blue glass. Statement 2, it is harmful for eyes to look directly into the flame. Option 1, both statements 1 and 2 are correct. Statement 1 is correct but 2 is incorrect. Statement 1 is incorrect but 2 is correct. Both statements 1 and 2 are incorrect. The samples we use for flame test is generally contaminated with sodium ions. It imparts yellow color to the flame so that the actual color of the ion we try to detect is masked. Cobalt blue glass acts as a filter and removes the yellow light. So, statement 1 is correct, but statement 2 is incorrect. Hence, option 2 is the correct answer. Statement 1 is correct, but 2 is incorrect. Question 4. A non-luminous Bunsen flame is a reducing flame, 2 yellow in color, 3 contains carbon particles, and 4 oxidizing flame. Non-luminous flame is oxidizing flame as the gas is burning in enough oxygen. The air holes are fully open and it appears blue. Luminous flame is reducing flame as it contains carbon particles. The air holes are fully closed and a partial burning of gas occurs. Luminous flame is yellow in color. So the correct answer is 4. Non-luminous flame is an oxidizing flame. Question 5. The chemical formula of borax is 1. Na2B4O7 10H2O, NaBO2, B2O3, H3BO3. Borax is Na2B4O7 10H2O. NaBO2 is sodium metaborate. B2O3 is boric anhydride. H3BO3 is boric acid. Question 6. Borax bead test for copper ions when carried out using non-luminous flame showed blue color when cold. With a luminous flame, the color observed in the cold will be 1 violet, 2 red, 3 grey, 4 yellow. When heated with boric acid in non-luminous flame, cupric metaborate is formed, which shows blue-green color. In luminous flame, the cupric metaborate formed is reduced to copper metal by carbon particles present in the luminous flame and shows a red color, and the bead become opaque. The answer is option 2. Question number 7. To prepare original solution for cation analysis, the solubility of the salt is tested first in 1. Hot water, dilute HCl, water, dilute HNO3. First we test the solubility in water. The order of testing solubility is water, then dilute HCl and heating, concentrate HCl and heating, dilute HNO3, and finally concentrate HCl plus concentrated HNO3 in the ratio 3:1, that is aqua regia. Question 8. Aqua regia is 1. 3:1 mixture of concentrated HCl and concentrated HNO3, 3:1 mixture of concentrated HNO3 and concentrated HCl, 3:1 mixture of concentrated HCl and concentrated H2SO4, 3:1 mixture of concentrated H2SO4 and concentrated HNO3. We know aqua regia is 3:1 mixture of concentrated HCl and concentrated HNO3. So option 1 is the correct answer. Question 9. Which among the following is a zero group cation? Magnesium 2 plus, lead 2 plus, zinc 2 plus, and ammonium 2 plus, ammonium plus. And we know the zero group cation is ammonium plus. Question 10. Nestle's reagent is used for identification of cation belonging to which group? Group 1, group 2, group 0, and a group 5. And it is used in group 0 for detection of ammonium ion. Nestle's reagent is K2HgI4. It forms a brown precipitate with ammonia. Question 11. For the identification of group 5 cation, the group reagent used is 1 H2S in presence of dilute HCl, NH4OH in presence of NH4Cl, H2S in presence of NH4OH, ammonium carbonate in presence of NH4OH. The group 5 reagent is ammonium carbonate in presence of NH4OH. Question 12. The cation or cations coming under group 3 are 1. Aluminum 3 plus and Fe3 plus, lead 2 plus, barium 2 plus and calcium 2 plus, ammonium plus. Group 3 contains ammonium 3 plus and Fe3 plus. Question 13. The group reagent for group 6 cation is or are H2S and HCl. No group reagent, and for ammonium oxide and NH4Cl. And group 6 there is no particular group reagent. Question 14. When the given salt is heated with the sodium hydroxide in a test tube, evolution of some gas occurred. When a glass rod dipped in HCl shown at the mouth of the test tube, dense white fumes are produced. This is due to the formation of 1 NH4OH, 2 NH4Cl, 3 NH3, 4 none of the above. And it is due to the formation of gaseous ammonium chloride. Ammonium sulfate, for example, when heated with sodium hydroxide, ammonia is produced. When we introduce a glass rod dipped in HCl, ammonia combines with the HCl and forms ammonium chloride. This ammonium chloride appears as dense white fume. Question 15. The solubility of an electrolyte M2A is 5 into 10 raised to minus 5 mole per liter. The electrolyte dissociate as shown below. The KSP of the electrolyte is. So we have to find out the KSP of this electrolyte, that is M2A. it dissociates into M2 plus and A2 minus. The answers are 1 5 into 10 raised to minus 3, 5 into 10 raised to minus 11, 2.5 into 10 raised to minus 14, and a 2.5 into 10 raised to minus 13. Since it is a numerical question, we have to find the answer by calculation. The general expression for KSP is M plus square into A2 minus. Since 2 moles of M plus are there and only 1 mole of A2 minus. Now the concentration of M2A is 5 into 10 raised to minus 5 mole. When 1 mole of M2A dissociate, we get 2 moles of M plus and 1 mole of A2 minus. Therefore, the concentration of M plus will be twice that of this value, 2 into 5 into 10 raised to minus 5. But concentration of A2 minus is same as that of this one. So that is 5 into 10 raised to minus 5 mole per liter. Now KSP is the product of these two. So therefore, KSP is equal to 2 into 5 into 10 raised to minus 5 raised to 2 into 5 into 10 raised to minus 5. Upon calculation, we get the answer as 5 into 10 raised to minus 13. So option 1 is the correct answer. Question 16. The solubility product of an electrolyte Mx is 1.6 into 10 raised to minus 11. The solubility of the electrolyte is 2 into 10 raised to minus 6 mole per liter, 4 into 10 raised to minus 5 mole per liter, 4 into 10 raised to minus 6 mole per liter, 1.5 into 10 raised to minus 6 mole per liter. And this also is a numerical question, so we have to first calculate. Let the electrolyte Mx dissociate as Mx giving M plus and X minus. 1 mole of Mx gives 1 mole of M plus and 1 mole of X minus. Let the concentration of Mx be S. So therefore the concentration of M plus will also be S. And that of X minus also will be S. So therefore KSP is S into S square. And the KSP is given, that is 1.6 into 10 raised to minus 11. So we can obtain the value of S as the KSP whole raised to half. We can write 1.6 as 16 into 10 raised to minus 12, the whole raised to half. So therefore the answer is 4 into 10 raised to minus 6. That is option 3 is the correct answer. Question 17. Zinc sulfide will not precipitate in group 2 when H2S is passed through the solution in presence of HCl. Option 1. Because solubility product of zinc sulfide is relatively high compared to group 2 sulfides. Because solubility product of zinc sulfide is relatively low compared to group 2 sulfides. Common ion H plus decrease the concentration of H2 minus. And the fourth option is both 1 and 3 are correct. For a salt to precipitate, the ionic product of its constituent ion must exceed KSP. In acid medium, dissociation of H2S is suppressed by the common ion H plus. So S2 minus is not enough to precipitate zinc sulfide, but enough to precipitate lead sulfide, whose solubility product is much lower than that of zinc sulfide. For zinc sulfide, the solubility product is 1.6 into 10 raised to minus 24. But for lead sulfide, it is 8 into 10 raised to minus 28. And copper sulfide, it is 6.3 into 10 raised to minus 36. The highest value is for zinc sulfide. So the correct option is option 4. Question 18. Dilute HCl saturated with H2S is added to a solution containing copper 2 plus, manganese 2 plus, zinc 2 plus and lead 2 plus. Which ion or ions will precipitate as sulfide? 1. Copper 2 plus and lead 2 plus, copper 2 plus only, manganese 2 plus and zinc 2 plus. Fourth option, lead 2 plus and zinc 2 plus. Since Dilute HCl is saturated with H2S. The dissociation of H2S is suppressed by H plus ions. So the concentration of H2S will be very low. Since the concentration of H2S is low, it may not be sufficient to precipitate manganese 2 plus and zinc 2 plus. Therefore, the correct option will be the first one, copper 2 plus and lead 2 plus. Question 19. Lead 2 plus precipitate as lead sulfide in group 2 also. This is because lead chloride is incompletely precipitated in group 1. The solubility product of lead sulfide is comparatively low. Lead sulfide is insoluble. All the above. So the answer is all the above. Lead chloride is incompletely precipitated in group 1. Similarly, the solubility product of lead sulfide is comparatively low. Lead sulfide is insoluble. So all these can be considered as the answer. Question number 20, statement 1. The third group cations are precipitated as hydroxide using NH4OH. Sodium hydroxide or KOH also can be used to precipitate hydroxides as they also furnish OH minus ions. Both statements 1 and 2 are correct. Statement 1 is correct but 2 is incorrect. Statement 1 is incorrect but 2 is correct. Both statements 1 and 2 are incorrect. Addition of NaOH or KOH will introduce additional cations. Sometimes these compounds may cause dissolution of the precipitate also. So the correct answer is second one. Statement 1 is correct. The third group cations are precipitated as hydroxide using NH4OH. But the second statement is wrong. So the answer is statement 1 is correct but 2 is incorrect. Group 3 cations are precipitated as hydroxide using NH4OH. But the precipitation is carried out in presence of ammonium chloride. The role of ammonium chloride is to control the concentration of OH minus ions. NH4 plus from NH4Cl act as a common ion. Prevent the precipitation of group 4 as hydroxides. All the above. In fact, NH4Cl serves all these three, 1, 2 and 3. So the correct answer is all the above. To control the concentration of hydroxyl ions available from NH4OH, NH4Cl is used as an electrolyte with common ion. Under these conditions, only hydroxides of aluminum and iron are precipitated. Question 22. In the third group, iron is identified as Fe3 plus and not as Fe2 plus since 1. Only Fe3 plus is stable. Option 2. Fe2 plus is not included in third group. Option 3. NH4OH is not strong enough to precipitate FeOH twice. 4. FeOH twice is more soluble than FeOH thrice. Ferrous hydroxide is more soluble than ferric hydroxide. This is because the solubility product of ferrous hydroxide is 8 into 10 raised to minus 16, which is much higher than that of ferric hydroxide, that is 1 into 10 raised to minus 38. We control the concentration of OH minus using the common ion from NH4Cl. Therefore, FeOH twice is more soluble than FeOH thrice. Option 4 is the correct answer. Question 23, an assertion reason question. Assertion: in cation analysis, if group 2 is absent, it is advisable to take original solution for testing the presence of group 3. Reason, it is better to use fresh quantity of original solution for testing each group for analysis of cation. Option 1, both assertion and reason are correct, and a reason is the correct explanation for assertion. Option 2, both assertion and reason are correct, but reason is not the correct explanation for assertion. 3, assertion is correct, but reason is incorrect. 4, both assertion and reason are incorrect. If the solution from group 2 is used, it will contain sulfide ions. Under alkaline condition, sulfides of group 4 will be precipitated along with group 3. So therefore assertion is correct. The use of fresh quantity of original solution for testing each group for analysis of cations may not be possible when more than one cations are present. So reason is not correct. Hence the correct option is assertion is correct, reason is incorrect. Question 24. Group 5 cations are precipitated as carbonates by adding ammonium carbonate in presence of excess ammonium chloride and ammonium hydroxide. Here NH4Cl is added to increase the dissociation of ammonium carbonate, to make the solution alkaline, to precipitate group 5 cations, to prevent a precipitation of group 6 cation, magnesium 2 plus as magnesium carbonate. The use of NH4Cl decreases the concentration of carbonate ion sufficiently to prevent a precipitation of magnesium carbonate in group 5 if magnesium is present. Ammonium acts as the common ion. So there exists an equilibrium between ammonium plus carbonate ion giving NH3 plus HCO3 minus. The equilibrium will be shifted towards right. So the concentration of carbonate will be reduced. So the correct answer is option 4, that is to prevent the precipitation of group 6 cation magnesium 2 plus as magnesium carbonate. Question 25. Assertion, group 0 should be tested first before separation to groups is carried out. Reason, group 0 is ammonium, and for group separation we add NH4 plus ions. Both assertion and reason are correct, and a reason is the correct explanation for assertion. Both assertion and reason are correct, but reason is not the correct explanation. Assertion is correct, but reason is incorrect. Both assertion and reason are correct. Here assertion is correct. Group 0 should be tested first because separation to group is before separation to group is carried out. And the reason also is correct because in the group separation we add ammonium ions. So both assertion and reason are correct. So option 1 is the correct answer. Question 26. A black precipitate is obtained when H2S is passed through a salt solution in presence of solid ammonium chloride and excess ammonium hydroxide. The cation present may be lead 2 plus, zinc 2 plus, manganese 2 plus, and nickel 2 plus. We know ammonium chloride and excess of ammonium hydroxide and hydrogen sulfide is the group reagent for group 4. So therefore we can eliminate lead 2 plus. And now we have zinc 2 plus and Mn2 plus and nickel 2 plus. Since we are passing H2S, these are precipitated as corresponding sulfides. And we know zinc sulfide is white in color, manganese sulfide is a flesh colored precipitate, but nickel sulfide is black. So we obtained a black precipitate. So the correct answer is option 4. That is the correct answer. Nickel plus hydrogen sulfide gives nickel sulfide which is black in color. Question number 27. Statement 1. In group 2, instead of H2S, we can use sodium sulfide in presence of HCl as group reagent. Sodium sulfide will precipitate group 2 cations as sulfides. Both the statements 1 and 2 are correct. Both the statements 1 and 2 are incorrect. Statement 1 is incorrect but 2 is correct. Statement 1 is correct but 2 is incorrect. If sodium sulfide is used instead of H2S, the sulfide ion concentration will be higher, and along with group 2, group 4 cations will also get precipitated. When H2S is used, H plus from HCl act as a common ion, suppressing the concentration of sulfide ions and prevent precipitation of subsequent groups. Therefore, option 3 is the correct option. A solution contains copper 2 plus zinc and zinc 2 plus ions. Copper 2 plus alone can be precipitated from this solution by adding 1 sodium sulfide and HCl, hydrogen sulfide and HCl, hydrogen sulfide, ammonium hydroxide and NH4Cl, ammonium carbonate, ammonium hydroxide and NH4Cl. Option 1 and 3 will precipitate both copper 2 plus and zinc 2 plus. Option 2 will precipitate copper 2 plus only due to the common ion effect. So option 2 is the correct answer. Yes, that is the correct answer. Question 29. A metal nitride solution gave white precipitate with a dilute HCl, and on heating the precipitate dissolves. On adding potassium chromate to the above solution, a yellow precipitate is formed which dissolved in hot NaOH solution. The yellow precipitate is due to the formation of lead chloride, lead iodide, lead chromate, sodium chromate. The precipitate is white in color and it dissolves in hot water, so it must be lead. And a lead chloride reacts with potassium chromate giving lead chromate, which is yellow in color. And this test is used as a confirmatory test for lead 2 plus. And if we add sodium hydroxide to lead chromate, it dissolves due to the formation of a complex. So the correct answer should be option 3. Question 30. A metal sulfide dissolves in nitric acid. On heating the reaction mixture for a long time, and when made alkaline using ammonium hydroxide, a blue color appears. The metal sulfide may be lead sulfide, copper sulfide, zinc sulfide, or nickel sulfide. We know copper sulfide, when it is heated with the nitric acid, it dissolves. On long heating, the sulfur is oxidized to sulfate and a copper sulfate is formed, which shows the blue color. So the answer is copper sulfide. Question 31. With a potassium ferrocyanide, copper 2 plus ions give a blue precipitate, bluish green precipitate, blood precipitate, chocolate brown precipitate. We know copper sulfate reacts with potassium ferrocyanide, giving copper ferrocyanide. And this copper ferrocyanide or copper hexacyanoferrate 2 is a chocolate brown precipitate, and it is used as a confirmatory test for copper. So the answer is 4. Question 32. When hydrogen sulfide gas is passed through a metal sulfate solution in presence of ammonium hydroxide, a white precipitate is formed. The metal is identified as zinc, iron, lead, or mercury. Since we are passing hydrogen sulfide, the metal sulfide should be precipitated and the precipitate is said to be white. So zinc sulfide is white in color. So the answer is zinc. Question 33. Hydrogen sulfide gas when passed through a solution of cations containing HCl. It precipitates the cations of second group but not those belonging to fourth group. This is because presence of HCl decreases the sulfide ion concentration. Presence of HCl increases the sulfide ion concentration. Solubility product of group 2 sulfides is more than that of group 4 sulfides. Sulfides of group 4 cations are unstable in HCl. And we know the answer, it is due to the presence of HCl which decreases the sulfide concentration. That is the correct answer. Question 34. Nickel sulfide is soluble in 1. Concentrated HCl, 2. Concentrated HNO3, concentrated H2SO4 and 4. Aqua region. Nickel sulfide is soluble in aqua region. That is nickel sulfide plus 2 HNO3 plus 6 HCl giving nickel chloride, nickel oxide and nitric oxide sulfur. Aqua region is a mixture of concentrated HNO3 and HCl in the ratio 1:3. Question 35. To the nickel salt solution which is made alkaline by adding NH4OH, dimethyl glyoxime is added. A bright colored precipitate is formed. The color of the precipitate is 1. Red, blue, violet and white. And we know the red precipitate is due to the nickel dimethyl glyoxime. So answer option 1 is correct. Question 36. Which of the following statements is correct? From a mixed solution of silver chloride and silver iodide, ammonia solution dissolves only silver chloride. Ferric ions gave deep green precipitate on adding potassium ferrocyanide solution. On boiling solution of K plus, Ca2 plus and HCO3 minus ions, we get precipitate of potassium calcium carbonate, K2CaCO3 twice. Manganese salt gives violet borax B test in reducing flame. And option 1 is the correct one. From a mixed solution silver chloride and silver iodide, ammonia solution dissolves only silver chloride. That is the correct answer. Question 37. To identify barium 2 plus ions, the group 5 precipitate is made into a paste with concentrated HCl and introduced into a non-luminous flame. When observed with naked eyes, the color of the flame appears as 1. Brick red, apple green, crimson red, 4. Green flame with a blue center. So this is a table with a naked eyes, cobalt blue glass, the ions indicated. So apple green flame or bluish green flame. So barium 2 plus provides apple green flame when we observe it using naked eyes, and a bluish green flame when observed through cobalt blue glass. Question 38. Match the experiments mentioned in column 1 with that of the cations given in column 2. These are experiments, these are cations. Option 1, 2, 3 and 4. When HCl is added to original solution and white precipitate forms which dissolves in hot water. Since the precipitate is soluble in hot water, it should be lead chloride. Also form an yellow precipitate with potassium iodide. That is lead iodide which is yellow in color. So we can match experiment 1 with 2, lead 2 plus. Second experiment is the group precipitate is boiled with the diluted NO3 and made alkaline using ammonium hydroxide. When acidified with acetic acid and potassium peroxide solution is added, chocolate brown precipitate formed. And the chocolate brown precipitate is copper ferrocyanide. So experiment 2 could be connected to copper 2 plus ion. The group precipitate is dissolved in dilute HCl and to one part of the solution potassium thiocyanate is added. Blood red color appears. And a blood red color is due to ferric thiocyanate. So 3 could be connected to 4, Fe3 plus. Experiment 4, the group precipitate is dissolved in dilute HCl by heating. When sodium hydroxide is added to one portion of the solution, white precipitate forms, which dissolves in excess sodium hydroxide. This experiment could be connected to zinc 2 plus. So the correct option is option 3. Yes. Question 39. Match the group reagents given in column 2 with the cations given in column 1. Options are A, 1, 2, 3, 4. And we know ammonium, so it could be connected to new group reagent. Group 0 has no group reagent. Now Al3 plus, that is ammonium chloride in presence of ammonium hydroxide, aluminum hydroxide precipitates. And a nickel, hydrogen sulfide in presence of ammonium hydroxide, nickel sulfide. And a barium as barium carbonate. So the correct option will be 2. That is the correct answer. Question 40. An assertion reason type question. Assertion. In the third group of analysis, ammonium hydroxide is added in presence of ammonium chloride. Reason. This is to convert the ions of the group into their respective chlorides. Option 1. Both A and R are correct. R is a correct explanation of A. Both A and R are correct, but R is not the correct explanation of A. 3. A is true, but R is false. Both A and R are false. To control the concentration of hydroxyl ions available from ammonia, ammonium chloride is used as an electrolyte with common ion. Under these conditions, only cations of group 3 will be precipitated. So assertion is true, but reason is wrong. So the correct answer is option 3. Question 41. Match the list. List 1, list 2, list 1, borax bead test, coordinated test, charcoal cavity test, flame test. List 2, conversion of X to Y, first by sodium carbonate, then sodium metaborate, cobalt nitrate, and heating. The option 1, option 2, option 3, and option 4. In borax bead test, sodium metaborate is found. When borax is heated, it is converted to sodium metaborate. So A should correspond to Q. Cobalt nitrate test use cobalt nitrate. So B should correspond to R. In charcoal cavity test, we heat the salt with the sodium carbonate. So C should correspond to P. And in flame test, we heat the substance. So D correspond to S. So therefore the first option is the correct option. Borax when heated loses its water crystallization and decomposed to give sodium metaborate and boric anhydride. This is borax and this is sodium metaborate and boric anhydride. Question number 42. Which of the following cations will give green color in reducing flame in borax bead test? Iron, cobalt, manganese, nickel. In non-luminous or oxidizing flame, iron forms yellow bead in the cold. Therefore, option 1 should be the correct answer. Question number 43. During the test for group 4, ammonium chloride is added with ammonium hydroxide. Why? Option 1, to increase the concentration of hydroxyl ions, to decrease the concentration of hydroxyl ions, to increase the concentration of H plus ions, to decrease the concentration of H plus ions. We can eliminate option 3 and 4. Ammonium chloride is added to decrease the concentration of H minus ions to prevent the precipitation of cations of the subsequent groups. Therefore, option 2 must be the correct answer. Question number 44. Given below are certain cations. Using inorganic cation analysis, arrange them in increasing group number from 0 to 6. The cations are aluminium 3 plus, copper 2 plus, barium 2 plus, cobalt 2 plus, and magnesium 2 plus. Choose the correct answer from the options given below. 1, 2, 3, and 4. We know copper comes under group 2, aluminium comes under group 3, cobalt group 4, barium group 5, and magnesium group 6. Therefore, the correct order should be option 1. Question number 45. Match the following. Cations, group reagent. Aluminium 3 plus, manganese 2 plus, lead 2 plus, copper 2 plus. Dilute HCl, H2S gas with dilute HCl, ammonium hydroxide with ammonium chloride, H2S gas with ammonium hydroxide. Option 1, option 2, option 3, and option 4. So from this table, aluminium 3 plus comes under group 3, and the group reagent is NH4OH with NH4Cl. Therefore, P corresponds to C. Manganese comes under group 4, and the group reagent is iron sulfide with ammonium hydroxide. So therefore, Q corresponds to D. Lead comes under group 1 as well as group 2. So therefore we can use two group reagents, dilute HCl as well as H2S with the dilute HCl. So therefore R should correspond to A as well as B. Copper comes under group 2, and for copper it is H2S with the dilute HCl. So copper corresponds to B. So therefore P to C, Q to D, R to A as well as B, and S to B. So the correct option is option 1.